Welcome. Today, we are looking at light waves. This is Topic 2 in your SS2 Physics series. This topic covers reflection and refraction of light. This topic is frequently tested in your examinations. Pay close attention. Let us begin. First, let me explain what light is. Light is a form of energy. It is an electromagnetic wave. It does not require a medium to travel. Light travels in straight lines. This is called rectilinear propagation. Light is produced by luminous objects. Examples include the sun, stars, and light bulbs. Light is detected by the eye. Light is essential for vision. It is essential for photosynthesis. It is essential for many applications. Understanding light is essential for understanding physics. Now let me explain the properties of light. Light has several properties. First, it travels in straight lines. Second, it can be reflected. Reflection occurs when light bounces off a surface. Third, it can be refracted. Refraction occurs when light bends as it passes from one medium to another. Fourth, it can be diffracted. Diffraction occurs when light spreads out after passing through an opening. Fifth, it can be dispersed. Dispersion occurs when light is separated into its component colors. These properties are essential for understanding optical phenomena. Now, let me explain reflection of light. Reflection is the bouncing of light off a surface. It occurs when light strikes a surface. The light is reflected back. There are two types of reflection: specular reflection and diffuse reflection. Specular reflection occurs from smooth surfaces. Examples include mirrors and polished metal. The reflected rays are parallel. Diffuse reflection occurs from rough surfaces. Examples include paper and wood. The reflected rays are scattered. Understanding reflection is essential for understanding mirrors and optical instruments. Now let me explain the laws of reflection. The laws of reflection govern the reflection of light. The first law states that the incident ray, the reflected ray, and the normal all lie in the same plane. The second law states that the angle of incidence equals the angle of reflection. The angle of incidence is the angle between the incident ray and the normal. The angle of reflection is the angle between the reflected ray and the normal. These laws apply to all surfaces. They are essential for understanding mirrors and optical instruments. Now let me explain the types of mirrors. There are three types of mirrors: plane mirrors, concave mirrors, and convex mirrors. Plane mirrors have a flat surface. They produce images that are virtual, upright, and the same size as the object. Concave mirrors curve inward. They converge light rays. They can produce real or virtual images. Convex mirrors curve outward. They diverge light rays. They produce virtual, upright, and diminished images. Understanding mirrors is essential for understanding optical instruments. Now, let me explain the image formation by plane mirrors. A plane mirror forms an image. The image is virtual. This means it cannot be projected on a screen. The image is upright. The image is the same size as the object. The image is laterally inverted. This means left and right are reversed. The distance from the object to the mirror equals the distance from the image to the mirror. These properties are essential for understanding mirrors. Now, let me explain the image formation by concave mirrors. Concave mirrors can form different types of images. The type of image depends on the position of the object. When the object is beyond the center of curvature, the image is real, inverted, and diminished. When the object is at the center of curvature, the image is real, inverted, and the same size. When the object is between the center of curvature and the focus, the image is real, inverted, and magnified. When the object is at the focus, no image is formed. When the object is between the focus and the mirror, the image is virtual, upright, and magnified. Understanding concave mirrors is essential for understanding telescopes and headlights. Now, let me explain the image formation by convex mirrors. Convex mirrors always form the same type of image. The image is virtual. The image is upright. The image is diminished. The image is always formed behind the mirror. The image is located between the focus and the mirror. Convex mirrors are used as security mirrors. They provide a wide field of view. Understanding convex mirrors is essential for understanding optical instruments. Now, let me explain refraction of light. Refraction is the bending of light as it passes from one medium to another. It occurs because the speed of light changes. When light enters a denser medium, it slows down. It bends towards the normal. When light enters a less dense medium, it speeds up. It bends away from the normal. The amount of bending depends on the refractive index. The refractive index is the ratio of the speed of light in a vacuum to the speed of light in the medium. Understanding refraction is essential for understanding lenses and optical instruments. Now, let me explain the laws of refraction. The laws of refraction govern the refraction of light. The first law states that the incident ray, the refracted ray, and the normal all lie in the same plane. The second law is Snell's law. It states that the ratio of the sine of the angle of incidence to the sine of the angle of refraction is constant. The formula is n1 sine I equals n2 sine R. n1 is the refractive index of the first medium. n2 is the refractive index of the second medium. I is the angle of incidence. R is the angle of refraction. These laws are essential for understanding lenses and optical instruments. Now let me explain total internal reflection. Total internal reflection occurs when light travels from a denser medium to a less dense medium. It occurs when the angle of incidence is greater than the critical angle. The critical angle is the angle of incidence that produces an angle of refraction of 90 degrees. When total internal reflection occurs, all the light is reflected. No light is refracted. Total internal reflection is used in optical fibers. It is used in periscopes. It is used in binoculars. Understanding total internal reflection is essential for understanding optical instruments. Now, let me explain the concept of critical angle. The critical angle is the angle of incidence that produces an angle of refraction of 90 degrees. The formula for the critical angle is sine C equals n2 over n1. C is the critical angle. n1 is the refractive index of the denser medium. n2 is the refractive index of the less dense medium. When the angle of incidence is less than the critical angle, refraction occurs. When the angle of incidence is greater than the critical angle, total internal reflection occurs. Understanding the critical angle is essential for understanding total internal reflection. Now let me explain the types of lenses. There are two types of lenses: convex lenses and concave lenses. Convex lenses are thicker in the middle. They converge light rays. They are also called converging lenses. Concave lenses are thinner in the middle. They diverge light rays. They are also called diverging lenses. Convex lenses form real and virtual images. Concave lenses form virtual images. Understanding lenses is essential for understanding optical instruments. Now let me explain the image formation by convex lenses. Convex lenses can form different types of images. The type of image depends on the position of the object. When the object is beyond 2f, the image is real, inverted, and diminished. When the object is at 2f, the image is real, inverted, and the same size. When the object is between 2f and f, the image is real, inverted, and magnified. When the object is at f, no image is formed. When the object is between f and the lens, the image is virtual, upright, and magnified. Understanding convex lenses is essential for understanding cameras, projectors, and magnifying glasses. Now let me explain the image formation by concave lenses. Concave lenses always form the same type of image. The image is virtual. The image is upright. The image is diminished. The image is always formed on the same side as the object. Concave lenses are used in glasses for short-sightedness. They are used in optical instruments. Understanding concave lenses is essential for understanding optical instruments. Now let me explain the lens formula. The lens formula relates the object distance, image distance, and focal length. The formula is 1 over F equals 1 over U plus 1 over V. F is the focal length, U is the object distance, V is the image distance. The lens formula is used to solve problems. It is essential for understanding lenses. Now let me explain the applications of reflection and refraction. Reflection and refraction have many applications. Mirrors are used in telescopes and microscopes. Lenses are used in cameras and projectors. Optical fibers use total internal reflection. Prisms use refraction to disperse light. Periscopes use total internal reflection. Understanding the applications of reflection and refraction is essential for understanding optical instruments. Now let me give you sample exam questions. Define reflection. Reflection is the bouncing of light off a surface. State the laws of reflection. The incident ray, reflected ray, and normal lie in the same plane. The angle of incidence equals the angle of reflection. Define refraction. Refraction is the bending of light as it passes from one medium to another. State Snell's law. N1 sine I equals N2 sine R. Explain total internal reflection. Total internal reflection occurs when light travels from a denser medium to a less dense medium, and the angle of incidence is greater than the critical angle. State the lens formula. 1 over F equals 1 over U plus 1 over V. Let me summarize. Light is an electromagnetic wave. It travels in straight lines. Reflection is the bouncing of light. The laws of reflection state that the angle of incidence equals the angle of reflection. Refraction is the bending of light. Snell's law describes refraction. Total internal reflection occurs at the critical angle. Convex lenses converge light. Concave lenses diverge light. The lens formula is 1 over F equals 1 over U plus 1 over V. Understanding light waves is essential for physics. Practice these concepts. When you have them down, move to topic 3.